Okay, 1.4 is a very important lesson now. We learn how to divide matrix, okay? So the inverse, we started seeing a lot of a theorem, okay, from this session. So inverse of a matrix. The purpose of us studying inverse of matrix so we can know how to divide a matrix, okay? And we have a few, so when is time, let me know, okay? So we're gonna have a few terminology first, okay? The first one is called the identity matrix. Identity matrix, okay? Remember that when we do algebra, we use a 1 as identity, right? Multiplication identity, we use a 1, isn't it? So anything times by 1 equal to yourself, that right? So for matrix, how do they do the 1? They use it this way to do it, okay? Let's say a 2 by 2 first. The easier one is a 2 by 2 to explain. It's like 1, 0, 0, 1, okay? This identity matrix, they use the I, okay? Like this, when they're 2 by 2, they use the I2, okay? Means a 2 by 2 matrix, okay? But most of the time, my students don't put that, I don't care, you know, because it really, right? As long as you know this identity matrix. So if a 3 by 3, you're gonna have 1, 1, 1, and then 0, 0, 0, 0, 0, 0. So this they use called the I3. Okay, now this represent 1 in matrix, okay? This represent 1 in matrix, okay? You guys follow me here? This is a 1. So from now on, do not use a 1, use a matrix, okay? So you have to shift your thinking, huh? So by the same idea, n by n, and then you're gonna have 1 in all diagonally, right? All 1, and then 0 here, and then what? 0 here. And these are in. I want to see if any students start to question me here. Do you think you can get an identity matrix for other for non-square matrix? Do you guys know that this is all square matrix? Is that right? Okay. Were you able to get the I for non-square matrix? What do you think? No, that's right. You look at the definition right here. Okay, identity matrix has been this kind of format. Okay, if you are not a n by n square matrix, you are not going to have an identity matrix. That gives you a little hint now, okay? You think in linear algebra, do they use a square matrix more than non-square? What do you think?
Square matrix.
Yeah, they use a lot of square matrix because square matrix give you a lot of a property, okay? Like they give you the trace, right? Trace only happen in square matrix, and then they give you the identity matrix, okay? Any question here? And then the second one, now second start to get a little bit of a critical thinking, okay? What's the inverse matrix? Well, inverse matrix also can only be used for square matrix. How come? Now these ones are for. So from now, if I say n by n, that means a square matrix, okay? N by n means a square matrix. Remember earlier I gave you guys an example. I said that 2 inverse times by 2 equal to what? 1, right? So you must need to give me a 1, the identity matrix. You guys follow me here? So therefore, if you want to divide a matrix, you must need to use the inverse matrix. And that inverse matrix should give me an identity matrix. So therefore, you can only have a square matrix for inverse. You guys follow me here? You can see the logic right there, right? So inverse matrix must be for n by n. Now here's a definition. How do you judge for inverse matrix? How do you find them? It's not easy to find the inverse matrix actually, okay? So let's say if A is a square matrix, A is n by n, okay? Now how do I determine this the inverse matrix for this n by n? Well, let me tell you this, not all the square matrix has an inverse. Not all the square matrices have inverse. Which kind without it will be, okay. So let me give you a note here. Right next to the property, right next to the definition. Not all n by n matrix has inverse. Okay. Or have, right? Now my English is not very good, so if I make mistake, feel free to correct me, okay? Not all n by n matrices have inverse matrix. In more case, you don't have an inverse matrix. Look at this one. If you have a whole row, a whole column, or whole row or whole column is a 0, you are square matrix, but you are not going to have inverse, okay? You follow me here? So A is the n by n first, okay? So here's how you judge for inverse, okay? If you have a matrix, there is a matrix called B, okay? There's a matrix B such that means the fact is going to be like this, okay? A times the B so equal to B times the A so equal to I, okay? That's right, okay? Now, you guys follow me here? So, if A is the n by n matrix, okay, I want to know if there's an inverse matrix for A, then I need to find a matrix, okay? I need to find a matrix called B, okay? If B can give me this property, like B times A times B same as B times A is equal to I, they both equal to I back, okay? Then B is a inverse then B is the inverse of A. Okay. Now sometimes they use the A inverse to devote for inverse. So like they use this one. So we can say B is equal to A inverse. Okay, you can do that, okay? B is the A inverse. And then that means that A has an inverse matrix, right? So for node number 1, this is node number 1, node number 2. Now I will, instead of go through all the theorems, I'm gonna just give you a note as the theorem sometimes, okay? So it's easy for you guys to see. The note is that, I lost my tracers. Okay, so, oh yeah, okay. So because the A has an inverse, we call the invertible, okay? If A has an inverse matrix, we call A invertible. It means that A will have an inverse matrix. That's very important. Invertible is very important in linear algebra, okay? Because that means you can do division, okay? So A is invertible. If A is invertible, we call A non-singular. So non-singular. Let me see how to spell. Non-singular. So invertible means a non-singular. Okay. Otherwise, we call A singular. And you see this expression very often on the internet. They will say, "Oh, this is a singular matrix." Singular matrix means that they don't have inverse. Okay. Non-singular means that they have inverse. So, as an engineer, you want to find a matrix non-singular. You want to find an inverse invertible matrix. Okay. You don't want to find a singular matrix. Okay. You want matrix non-singular. You guys follow me here? You want it to be invertible. Because only invertible allows to do a lot of stuff. Any question here? Okay. So we learn identity matrix, we learn inverse, now we learn how to find inverse matrix. So this become a algebra part again. So this is a fun part. What time?
9:14.
Huh?
9:14.
9:14, okay. Sorry about this class because I want you guys to be the best on your field, so I don't want to hold back on any of the knowledge that I know is important for you guys. So I might go a little bit fast, so that's why the code the video so that you can watch it, okay? Number 3, and the method. The method to find matrix, okay? No, did I say that? The method to find inverse matrix, not just matrix, okay? The method to find inverse matrix, and then we have 2 by 2, and then we have 3 by 3 or above, okay? 2 by 2 is very easy, okay? So let's say if a matrix A is equal to ABCD, 2 by 2 is easy. You guys probably learn about 2 by 2 in your previous class. So A inverse equal to 1 over the determinant, okay? AD subtract BC, okay? Then switch these 2 numbers and then add the negative for these 2, okay? Switch them, so DA. So switch the A and D, the main diagonal, switch them, okay? And then negatively opposite to the other diagonal. We only care about the main diagonal. Another one, I don't think there's a name for that. Okay. So the main diagonal is this is called the main diagonal, okay? The other one, I don't know if there's any name or not. I don't remember seeing another name. So this is for 2 by 2. A inverse, that's easy, right? So 2 by 2 is very easy. But you know that 2 is in life in general, you don't see 2 by 2. If you're gonna go into, even for econ major, I heard econ major, the smallest matrix is 500 by 500. Because this number is called the data. So just think about how many data you have, right? Right now it's all into big data, okay? That's why they're AI, right? It's all because of big data, right? So you can see that they have many data. So each number represents one data. So you can see, but this just for the using for the book. That's it, theory. Okay, teach you is easier that way. Now, if we have 3 by 3 or above, okay, if you're gonna get 3 by 3 or above, then you're not gonna do like that way. There's no way you can do like that way, right? So what you do, you're gonna get the matrix A. Okay, and then you're gonna go to a identity matrix, put identity matrix right next to it. Okay, and then you're gonna perform Gaussian elimination. Perform Gaussian elimination, make it to be a reduced echelon form. So now this is the A, this is the I, right? So you're gonna perform Gaussian elimination, means a row operation, and then you're gonna make it to be a reduce a row echelon form, so become I, and then this will be A inverse. Okay, so you kind of like a switch the position. So your A, put an I here, okay, so 2 matrices together, you perform it, and then you should get back your I, and the next one you get is your inverse. This is you use it often. Okay, if you have to write a coding, that is your coding. No one gonna do a 2 by 2. No, this is for 3 by 3 or above. Okay, but of course in class we are not gonna do more than 3 by 3. But in your homework you might see higher. But in the exam, yeah, I'm not gonna give you more than 3 by 3. So 3 by 3 for the highest I will give to you because that only for little time. Any question here? It's what time?
9:19.
Oh, okay, so it's almost time. So, okay. Now if you are given this one, to find that one, you do the same thing, okay? If you're given A inverse, you can do like that way too. If you're given A inverse, you define A, you want to find the original matrix back, you do the same thing. Okay, you perform the same thing, you're gonna get I and then what? A. So if you want to reverse back, then you write a code to reverse back, okay? Okay, so maybe I just do one problem, then we're done for today, and that will be number 6. Then the proof, we're gonna start next week. So on the homework, you can only do up to here, okay? And I will do the 3 by 3 next time, so I will just do 2 by 2. 2 by 2 is very easy. So number 6, you have B equal to 3, 1, 5, 2. Okay, and to find the inverse for this one, we just use a formula. So that's a 1 over these two multiply, so 3 times by 2 subtract 1 times by 5. This S is what? Anything realized, this S is determinant. Okay, so 1 over determinant actually. But I couldn't write that yet because we haven't learned determinant. So that's how math is. Okay, they go by critical thinking. Means if you are not, they haven't present you the knowledge in the book, even though you learn it from other class, you cannot use it. Okay, I learned it when I was in college. Our professor said that even though you learn it from your previous class, you still cannot use it here because in this book, it's not present that way. So I remember that. So he said that you can use the previous chapter, previous session, but you cannot use the previous book, okay, the previous class. Except, of course, the basic algebra, those you could, not all the operation, those you could, those. But theorem, okay, all the theorem has to be used in the current. So split this 2, okay, so 2 and 3, and then what? Opposite this 1. Okay, what do you get? This is a 6, oh, this is nice, huh? 6 subtract 5 is 1, that right? So that just become 2, negative 1, negative 5, and then 3. So that's basically for today's material. And then because it takes time to do the rest of it, so we're going to do it next time. I need to call roll.